Reconciling assets and liabilities is relatively easy when they come in their natural units, that is, in their whole undivided units. Let's take for instance that we can have lend and borrow apples. When we do that, we should be conscious of the fact that apples exist in their natural units of one apple each. No apple tree produces apples in forms which are divided. Every apple on its parent tree is existing as a whole apple, not divided apple. That is what I mean by natural units, apples existing in their natural units, undivided whole units. Like apple, many other resources of life exist in that like manner. When we carry out account keeping, or when we keep account of assets and liabilities which are whole, we find the exercise easy. That is, when we do accounting with assets and liabilities which reflect things that are not divided, then the exercise can be quite easy. But today, there has come to be an added challenge to that process. Adding, subtracting, multiplying, and dividing has become a bit more challenging. That is because today, numbers no longer exist just as whole numbers. Instead, they have come to exist as portions of whole things. Take for instance that somebody, instead of giving and receiving apples in whole forms, has to do so in portions. Yes, you can agree with me that it is possible to break apples into portions and then have and owe, that is, receive and give. Yes, that is possible. In today's world, that is just practical. When we add, subtract, multiply, and divide, the numbers of apples exchanged between two persons, that exercise is easy. But when we start dividing apples in portions, you break one apple into 5 and pick one, break another apple into 10 and pick one. You bring one portion from this group and one portion from this group, and you join them together. And somebody says, "What amount of apple do you now have? Tell me." What will you say you have? Will you say you have 2 apples? No, you will not say that. That is because the other one is not one whole apple. The other one is not one whole apple. If both have been 2 whole apples, yes, that will be possible. You can rightly say that you have 2 apples, but in this case, you have portions from this and portions from this, and then 2 of them were joined together. Because of that, you can't rightly say you have 2 apples. You are just doing reconciliation with portions of whole number units. That challenge has come to be, and we must face it. On that note, I say, welcome to the world of fractions. This is part 3 in my series called Foundations of Mathematics. In this topic, I seek to explain and guide the way into carrying out number operations involving addition, subtraction, multiplication, and division of no longer whole numbers, but portions. Please find the proposed content of this presentation. Let us start with the first objective, our first shot, that is introduction and the emergence of fractions. Now let us briefly learn how what is today known as fractions came to be. Let us learn emergence of fractions. Please permit me to use these circles which you are seeing on the screen to tell in a brief sense how fractions came to be. Each circle represents an orange. Each of these circles represents an orange. And recall that oranges have always been in existence throughout history. Please count how many oranges you are seeing on the screen. What is your result? You might simply conclude that this question should not come up. Very soon, you will know why I'm asking that you tell me how many oranges you are seeing, which, in this case, are seen as circles. Please again, count how many oranges you are seeing on the screen. Okay, let me count. And when I give my result, cross-check it. That is, try to compare my result with what you got. And here it comes. It is 5 oranges. Is that what you got? Certainly, you should have gotten that because this is an orange. This is also an orange. One whole orange. Another one whole orange, making 2 whole oranges. Here we have 1 whole orange, 1 whole orange, 1 whole orange, making 3 whole oranges. Then 2 plus 3, that is 2 whole oranges plus 3 whole oranges will give us 5 whole oranges. That is straightforward and easy. You agree with me? When oranges became scarce, people started having both whole oranges and portions of one orange to eat. Yes, at a time in history, oranges and other things that God gave to mankind became scarce. Gradually, though, all things became scarce. You can agree with me that today you don't always see what you are seeking. You want to eat oranges, but how easy has it been to find enough oranges to eat? Before now, it was not difficult to find oranges and other provisions of nature. But at a time in the past, oranges and some other resources of life became so scarce that people had to divide one thing into portions and pick from them. People began to, for instance, divide oranges, one orange, into portions and pick those portions to eat. So people began to eat both whole oranges and portions of oranges. Now, notice what follows. And here they come. Look at each of the oranges again. Each of these 5 oranges, just take a look at it. Is each of them still a whole orange? Anyway, we can argue that the whole of this is still a whole orange. But notice that we now have portions. Each of these 5 oranges has been divided into portions. In this first row, each of the oranges has been divided into 3 portions. 1, 2, 3 portions. 1, 2, 3 portions. In second row, that is this row, each of the oranges has been divided into 5 portions. 1, 2, 3, 4, 5. The same thing applicable to this and this. If you pick one portion from this first row of oranges, how will you describe what you have picked? Let's see. Obviously, when you pick one out of these 3 portions, we describe that one portion as 1/3. That is why this 1/3 is written inside one of the 3 portions, just to highlight that. What if you pick one portion from this second row? How will you describe what you have picked? Again, let us find out. Similarly, If you pick 1 out of the 5 portions, you describe what you have picked as 1 over 5. That is, 1 portion is equal to 1 over 5. What about picking 2 portions out of this row? That is, pick any of these whole oranges broken into 5 portions, and from the 5 portions, pick 2. Let us simply assume that from this first orange, I pick this and pick this. Let me label the portions A and B. And here they come. This portion is A and this portion is B, just for simplicity. If I pick this portion and pick this portion out of these 5 portions, how would I describe what I have picked? Surely, it is going to be described as 2 over 5. Let's see how it is written. And here it comes. 2 portions is equal to 2 over 5. That is, these 2 portions are described as being 2 over 5. Now, think about it. What if somebody picks this 1 over 3, that is 1 out of these 3 portions, and comes to this second row and picks these 2 portions, that is this portion from this orange, this portion from this orange, and this portion from this orange, that is this plus this plus this. Of course, we have known that these 2 put together are described as 2 over 5. That means that A plus B is equal to 2 over 5. So what if we have this portion, and this portion? How would the person describe the total of what he has gathered? Let's find out. Now, as you can see on the screen, if we pick 1 portion from this first row, like this one, we call it 1 portion from this row. If we pick 2 portions from one of these oranges in this row, we call them 2 portions. So we now say 1 portion from this plus 2 portions from this. How do we describe it? Obviously, it is described as 1 over 3 plus 2 over 5. Now, what will you say is the total result of this addition? 1 over 3 plus 2 over 5. What exactly will you say is the answer? If we try to find the answer to 1 over 3 plus 2 over 5, that is 1 over 3 plus 2 over 5, and we don't succeed, that is, we try a bit to get the answer to that expression and we fail to get the correct answer, should we abandon it or should we try harder? No, we should not abandon it. Why? It is because it has become a real-life challenge to add, subtract, multiply, and divide with portions of just anything we encounter from time to time, not just oranges. Note the expression, real-life challenge. What it means is that what you are seeing on the screen represents a real-life challenge of people that lived before us and even today. You can't run from a problem that keeps coming to be in front of you. You can't avoid some real-life challenges. If you avoid them, you are prepared to end your life. Then, if you surmount these challenges, you are prepared to live. As I said earlier, it is not just portions of oranges that we can encounter in real life. We could encounter just portions of anything. We could encounter portions of apples, watermelons, coconuts, and just everything and anything. People who lived before us encountered this challenge and could devise a way of meeting the challenge because they couldn't avoid it. They could not avoid the challenge. It was something that had come to stay with them. So because they couldn't avoid this challenge, they devised a way of solving that or meeting this challenge. Today, we too cannot avoid it. Why? Because we see the same challenge that the people that lived before saw. So we learn it. We must also learn it the same way the people of the past learned it. Now, compare what is happening here or what has happened here to what happened in the beginning. Remember adding 2 whole oranges to 3 whole oranges to give us 5 whole oranges. But at this point, you have 1/3, a portion, and then 2/5, also some portions. Adding, subtracting, multiplying, and dividing with whole numbers are straightforward and easy. But doing same with portions is quite challenging. Now that we have resolved that we're not going to shy away from this challenge of adding portions, subtracting portions, multiplying with portions, and dividing with portions, let us briefly introduce terms that have become popular in describing this aspect of mathematics. First, this portion of a whole is called fractions. This portion of a whole is called fraction. So we have been using the word portion for quite a while now. From this time onwards, you could choose to call it fraction. So portion of a whole thing is called fraction. Let us pay attention to the screen and see a more technical definition of fraction. Let's see. And here it comes. Fraction is the magnitude of a specified number of equal portions of one whole thing. Do you understand that definition? This word magnitude simply means the size of something. This word specified means that the number is just definite. The number of portions is known. And then, already we have known what portions are. And I also believe that we know what is called one whole thing. Join these ideas together and you will come to have a more holistic approach to understanding the concept of fraction. Again, fraction is the magnitude of a specified number of equal portions of one whole thing. As example, we get back to our foregoing diagrams. This 1/3, for instance, is a fraction. 1 is a specified number of portions. What if I write 2/5? The 2 is also a specified number of portions, picked from equal portions of one whole thing. We assume that each of these portions is equal to one another. Whether our assumption is correct or not, the message we want to hear is that each of those portions is equal to the others. If each of these portions is not equal to others, it will be wrong to call it just a fraction. It is this word equal that makes this portion become called a fraction. When this portion is not just equal to others, we can just loosely call it a portion. But because each of them is equal to others, we now technically call each portion a fraction. So, one portion, that is a specified number, taken out of 3 equal portions of this orange, is example of a fraction. So far, do not forget how we described these 2 portions we picked from here. Already we see that this 1/3 is for one portion we picked out of this, and this is one portion we picked out of this. What about these 2 portions we picked out of this? Though we have once seen it, let us recall. And here comes the reminder. This portion plus this portion put together, that is this way, is described as 2/5. Before we conclude, this section. Let us learn how to interpret this 1/3 and similar expressions, and also 2/5 and similar expressions. Please watch out. And here they come. The first is that 1/3 means 1 picked out of 3. Recall, 3 equal portions of one thing. And 2/5 means 2 picked out of 5. Again, 5 equal portions of one whole thing. What else can we learn as we try to get familiar with this concept of fractions? Please listen. Okay, at this point, it is important to note that the total number of portions to pick from is called denominator, while the number of portions picked is called the numerator. That is, since we explained 2/5 as meaning 2 picked out of 5, the implication, therefore, is that with this 2/5, in view of this statement made earlier, which I believe you have understood, this 2 is the numerator, while this 5 is the denominator. Now, let's go back to this statement. It says, the total number of portions to pick from. It is these 5 portions that the 2 were picked from. Recall, we have 5 portions here, from which 2 were picked. All these 5 portions to pick from are the things referred to as denominator. Then these 2 portions that were picked out of the 5 are the things that we refer to as the numerator. Therefore, the number to pick from is denominator, but the number picked from those number of portions is called the numerator. So in other cases of fractions and expression of fractions, I believe you can tell which one is the numerator and which one is the denominator. What about this here? In 1/3, we have 3 portions here. We have 1, 2, 3 portions. The total number of portions to pick from, which is this 3, is called denominator. Therefore, in each of these 2 oranges, broken into 3 each, the denominator is 3, but 1 is picked from each. Therefore, 1 is the numerator. I just believe that with these few examples here, you will be able to grasp the meanings of the concepts of numerator and denominator. In this whole topic of fractions, our main objective is to learn the arithmetic of fractions. That is, to learn how to add, subtract, multiply, and divide with fractions. That does not mean that all we're going to see in this topic is just how to add, subtract, multiply, and divide with fractions. We're going to see some other concepts about these fractions. But bear it in mind that every other thing we're going to see in this topic, apart from the arithmetic of fractions, is for one objective. It is just for us to use those other things to pave way for us to understand properly how to add, subtract, multiply, and divide with fractions. Before we go further into the things that remain in this topic, there is one important caution I would like all of you to take note of. What is this? Please notice what follows. Now, here comes the caution. Look at this, and look at this. This is 1 orange broken into 3 and 1 portion is picked. This might be a bigger orange or another fruit that is much bigger than an orange, also broken into 3 and 1 portion is picked. We describe this one portion as 1/3. There is no rationale to describe this one portion as something else apart from 1/3. Therefore, based on that, this one portion is 1/3, and this one portion is also 1/3. Just as this arrow points to this 1/3, corresponding to 1/3 of this one small range, and this arrow points to this 1/3, corresponding to 1/3, that is 1 out of 3 portions picked from this bigger orange or another fruit. The question is, do you think that this 1/3 and this 1/3, though looking just identical, are the same in magnitude? That is a challenge, and that is the point of caution. Therefore, this 3 and this 3 do not tell us the size of the portions. Instead, they only count number of portions. Because of that, in fractions, we do not concentrate especially on the size of the portions. Instead, it is the number of portions from which we pick that we concentrate. This type of arithmetic of fractions involving the same value attached to denominator, but in actual sense having different magnitudes, would not be discussed in this topic. Instead, we're going to concentrate on arithmetic of fractions in which the denominators are just considered to be of equal magnitude. Perhaps a different topic could be devoted to discussing addition, subtraction, multiplication, and division of fractions in which denominators have different magnitudes. Just like it is not possible to get the correct answer from 1/3 plus 1/3, knowing the truth about the sizes from which they were picked, it is not possible for us to develop it in this basic concept of fractions. Before we go to the next section, please try out the following questions with a view to finding the answers to them. And here comes the checkpoint. It says, interpret the following expressions with respect to fractions. A, 3/7. B, 1/9. C, 11/14. C, 5/12. I just hope you know what I mean when I say interpret. In the following section 2, we're not going to plunge headlong into arithmetic of fractions. First, there are pertinent things we have to learn to pave way to learning that. Section 2 talks about characteristics of fractions.